All right. There's three things that you need to understand when understanding changing of the seasons. You need to understand that there's a sun, there's an earth, the earth exists on a tilt, okay? The earth rotates, and the earth revolves, okay? So, imagine this black pepper is the earth, this organic soup is the sun, the earth exists on a tilt, so roughly 23 degrees, okay? It rotates on its axis, but it revolves around the sun. So one rotation is a day, and then one revolution is 1 year. So there's 365 rotations in 1 year. The earth rotates 365 times as it revolves around the sun one time, okay? So, how this looks in a two-dimensional drawing, something like this. This is a two-dimensional drawing. If this is the earth, this is what we call the axis of rotation. So like I said, that's the earth. It's on a slight tilt. It's not fixed in space. If it was fixed, it would be the same temperature all year round. All there would just be day and night. But there's not. It's on a tilt. The earth revolves around the sun on that tilt. As a result, certain portions of the planet get different exposure to solar radiation at different times of the year. So first we have to understand what causes the day and the night before we can understand the seasons. So that's the South Pole, North Pole, axis of rotation. The planet revolves 365 times once every year. Okay? One revolution equals 1 year. 2 revolutions equals 2 years. 365 rotations equals 1 year. 1 rotation equals 1 day. Okay? So, this is what causes the changes of the season. If you look, you can see. Let's start with where we would be right now. So, we're in the northern hemisphere. This is probably where New York City is. Okay? It's springtime right now. Okay, we have not a extremely high degree of solar radiation right now, but not a small amount. So it's a little bit in between what our spring and summer is. Okay, so during the springtime we get this degree of solar radiation, and then incrementally that portion of the planet is going to experience a huge amount of solar radiation. So this is still New York City. Okay. Let's look at New York City during our winter, right here. When the earth rotates around the sun, it's fixed in space. So when it gets over here, the South Pole is facing towards the sun. So the days are still occurring, but the South Pole is experiencing a lot more solar radiation than the North Pole. Vice versa. When the North Pole is over here, it's experiencing a lot more solar radiation than the South. Okay? Then there's a little bit of intermediary places. That's what we call spring and fall. Okay? So I repeat. A quarter revolution is 1 season. Another quarter revolution is another season. Another quarter revolution is another season. And then another quarter revolution is another season. 365 times the sun comes up. And the sun goes down, sun goes up, sun goes down. But when the sun is up on one side of the earth, it's down on the other, and vice versa. So let's bring it back to the earth and the sun. Okay? The earth is on a slight tilt. Okay? Let's say that this is China, this is the United States. It's daytime in China, it's nighttime in the United States. Half a rotation. Now it's daytime in the United States. It's nighttime in China. Once again, and the whole cycle continues 365 times all the way around the sun. Okay, so let's bring it back. Let's tie this all together. So let's say that we're living in Australia. Okay, we're right here. There's a very small amount of solar radiation hitting this portion of the planet. Okay, so that's what their winter would be. In wintertime in Australia, it's summertime for us. Okay, so this is us. There's Australia. The Earth rotates. This is its fixed spot in its revolution. The Earth is continuously rotating. It's very cold in Australia. It's very hot in New York City. If you skip 6 months down the road, it's very hot in Australia. It's very cold in New York City. It's all about the tilt. What portion of the planet, because of the Earth's tilt, is experiencing the most direct sunlight at that given moment? And this does not happen like a coin flip. It happens very incrementally. Okay, that's why we have 4 distinct seasons. And we really could break it up into 8 seasons if we wanted to, but we just don't have names for it. Just like deep February is extremely cold, and late March is still a little bit cold. Okay, just like late October is starting to get into the cold months, but it's not quite winter. Okay, incrementally receives more or less direct sunlight depending on what region of the planet you're on. Okay, so I repeat, let's say that we're in Southern California. Okay, Southern California during the springtime, Southern California during the summertime, Southern California during their fall, and then during their winter. Okay, if you are on the Earth's equator, now you can look at this on a map of the Earth. You can see that on the equator, at all seasons or all times of the year during this revolution, this portion of the planet on the equator is always getting a very large amount of direct sunlight. Just like the North Pole and the South Pole are always, no matter where they are during the revolution, are always getting very little amounts of direct sunlight. That's why it's always cold up here, no matter what season it is. And that's why it's always hot right here. But if you're like somewhere in the middle, like people living in Argentina, South Africa, Australia, China, New York City, Midwest, there's going to be fluctuating seasons, and that's because of where we are during this revolution process. But 2 things will always happen. The Earth will rotate, day and night will come, and the Earth will revolve. Okay? Thank you, guys.